All right. Um, Looks like we're live. Okay, cool. We're live. Uh, I just wanna quickly test this microphone. Okay, it works. All right. So, today's gonna be a little different. I'm not gonna make some 3D project or whatever, but I am kind of developing this. It's like a plugin, but it's not really a plugin. It's like a well, it is kind of a plugin, but like a simple version because I made it with Espresso. And yeah, so oh wait, let me give you like what I'm doing here. So what I want to do is replicate this thing called spin tool in Blender, which Cinema 4D doesn't have, but it is amazing. So for example, if I make a cube here, right? So I'm in Blender, and then I do stuff like I don't know, subdivide, oops, subdivide, and then I select some random polys, then I extrude it, and let's say I want to make like a pipe where I want to extrude like this, and I just want to keep extruding like this to there. So how do you do it? Well, in Blender it's pretty simple. So first you set your 3D cursor, for example, like right here, and then just type spin, and yeah, it'll do that for you. And you kind of have to adjust this. You can just steps, and then whatever. You can do a lot of things. As you can see, that's pretty cool. Wait, I do wonder what happens if I do it from here. Does it work? Oh, it still works. Nice. So yeah, anyway, that's the spin tool, right? Which is pretty, it's really cool. It's really, good. But Cinema 4D doesn't have this kind of thing. I'm just kind of checking here. Okay, yeah, Cinema 4D doesn't have this thing. Well, we do have something like matrix extrude. So for example, you go to matrix extrude right here. And then you can just do stuff like that. But it is hard to do. Like, you have these steps and the move, the rotate values. It's like you have to well, you have to perform some, counting and calculations, which isn't really ideal, I think. Well, in my opinion, and also it's kind of inaccurate. Like, look at this. Because this thing doesn't actually spin things the way spin tool does. It just kind of, extrude, rotate, something like that. So you actually have to adjust it with some of these. I forgot. Hold on. So you have to like do something like that. But it is guesswork. It is a lot of guesswork. And yeah, if you're making stuff like for like decoration, then it wouldn't really matter. But if you want to make stuff with actual um real dimensions and stuff like that, it's gonna be hard. It's gonna be very inaccurate. So yeah, it's really frustrating how Cinema 4D doesn't have this. Well, the other way you can do it is it's a bit tedious, but you just rotate this and like multiple times while holding control, and make sure you have quantize open. So you want to go to I forgot the shortcut. Control Q, or so let's say I want to go for 90 degrees and I want to change the rotate to something like, yeah, let's go 5 is fine. All right, okay, so I select the cube, I enable quantize, so now everything I do does that. Actually, while we're at it, I want to update my palettes here. Enable quantizing. Yeah, put that there. It's a pretty useful thing. Okay, so So what we do is we drag this axis here, and then we just lock certain axes. In this case, I wanna do the X, so I lock the Y and Z, and yeah, that's all you do. Just gonna do that. Just keep doing it and make sure you don't skip any. You can kind of spam it, but yeah, it can be inaccurate. There you go. It took us like 30 seconds to make that, which is, well, ridiculous, right? Like, it's just not ideal. So I guess our only option is matrix extrude, right? But the thing about matrix extrude is that it does some stuff inaccurately. For example, if we do the same thing we did with the blender, so we subdivide a lot, and then we just select some random polygons like this, and then we do a matrix extrude. Oh, right here, you can see that it extrudes individual polygons. We don't want that. So what we can do is melt them, which just turns them into one giant n-gon. And when you do it, yeah, this happens. The coordinates are really messed up. Yeah, it doesn't know how to figure it out, right? You can kind of cheat it by disabling this polygon coordinates thing, but it's still really messy. Let's just look at this, okay? For example, if I just normalize everything, hold on. I think I accidentally did something really bad. Okay, so you do your thing, you try to rotate it, then that happens, and then you try to fix it. It's not doing the same thing anymore. It's like, yeah. Oh yeah, wait, I haven't melted it yet. I'm sorry. Okay, there it is. Like, see how it's like really glitchy, and yeah, it's just really ugly, right? So the actual, like, the most accurate method I know is by just using a matrix extrude from here. But it is a deformer, so you gotta like make some selection stuff. So you just make selection, then go to here, mo extrude, and then we got polygon selection. Just drag your polygon selection there, and yeah, it kind of works. You just set this to 1 first, and then just set one of these rotations, and yeah. So yeah, this one is cleaner. It definitely works, right? So per step is more recommended. But yeah, you're still getting the same problems as before, which is these inaccurate sliding things, which you have to fix by doing these sliders and stuff. So what I want to do is make something that just calculates everything for you, and it turned out to be harder than I expected. Well, I already tried to make one, which is this version. And well, it kind of works, I guess. So I use a multiplier thing for the shift, and you can see like it retains itself. Like as you change the radius, it doesn't retain well when you change the angle, but it does retain when you change the subdivision. Which this one is kind of like the raw version where there's not really any calculation involved. If you can see, if I change the subdivision, it also kind of moves in a different way. So yeah, I want to figure out the math behind this and hopefully just create my own little espresso program for it, and yeah, maybe I can make something that's useful, because yeah, I find that I have to do a lot of these in my day-to-day modeling. All right, so I guess we should begin. I'm gonna open up whiteboard because it makes it easier to me to write stuff. I have my pen here. All right, Ignore these. I'll just make a new one. Am I still alive? Yeah, I'm still alive. Okay. Alright, so we can just start drawing now. Great. Okay, so yeah, honestly, I don't even know where to start. Wait, I already sketched some stuff on the paper before. Okay, so basically, like I said, this thing doesn't, you know, rotate it along some point, right? It just, yeah, just extrude, rotate, and then from this perspective, just extrude, rotate. From this perspective, just extrude, rotate. So like, it creates like this weird cyclone effect. As you can see, I don't know what to call that, but it basically creates this like shutter camera futuristic thing, which is not what we want. So that's why I have this shift value here to kind of shift it to precision. But yeah, it's still tedious and yeah, it's a lot of guesswork. Okay. All right, so starting the math. So this is what it's doing. First thing, where's my pen? Hold on, it's broken. Oh, there it is. Wait, why is my cursor not visible? That's not right. Oh, I think because I haven't selected. Oh, okay. Here we go. Okay, so here's what we do. So what it's doing, right, is it, does this, move it by some certain thing. I call this PZ because that's literally what it is. And then it does a rotate on it, so it becomes this. But it doesn't have a clear axis, clear what do you call it? Like, yeah, that thing. It doesn't have a clear axle or something. What we want is something like this. So there's an angle right here, and it has a clear center point, and it does this. So how do we do that? Well, all we want to do is figure out the px, right? Px is basically this delta movement that goes up, that transforms this to this. So now this has an angle, and so is this one. So yeah, I kind of have to revisit some high school maths for this. A lot. Anyway, so this is what I kind of came up with. So this is what we're doing. Hold on, let's see. That's a bad idea. I should do it right, like here. Okay, and then there. So this is the center point of this polygon, and this center point of this polygon. And before it was lifted up with this px, it used to be right here. So this distance right here is our pz, and this is our px. And this, if we want to calculate this, well, we can use the cosine law, which I'll explain in a minute. So this is the point, circle point, and then there is a certain angle between these two. I'm gonna make it theta or theta. I don't know. Okay. And right here, this is R, and they're both exactly the same. This is the ideal situation, right? Ideal situation. So yeah, this is what we're dealing with. And then okay, and then so to figure out this, I'm gonna call it something like A. It's actually kind of, well, it's the cosine rule, right? So A is just square root of r squared plus r squared, which makes 2r squared, minus 2rr, which is just 2r squared again. And then we do a cosine of this the angle, cosine theta, like that. Oops. So yeah, there it is. That's our A value. And if you notice, this is also a right triangle right here. So we can do a Pythagorean theorem. So pz squared plus px squared equals, this squared is just this, but cancel the square root here, so just 2r squared minus 2r squared cosine theta. I just want to make sure my string is working. Yeah, okay. So p squared, blah blah blah. And then we can simplify this right hand side. So 2r squared 1 minus cosine theta. Okay, so here's what we do. So this is our defined, this is defined one. This is the one we actually define, like, yeah, the offset. While this is one we don't know, and also the r we also don't know. So we'll end up getting two different constants that we don't really know the value, which I don't know if it's gonna work, but yeah, it's just, yeah, fuck. I wish I could think of a better solution. So the thing about this, right? The distance here is the same as pz, but it is rotated like this. We want to find r, which is the distance between the center and this, right? And then, so what do we do? R, we know this length. Do we know px? No, we don't know px. All right, I'm thinking. This is really hard. Okay, actually, I thought of something, but I forgot. Like 15 minutes before the stream. What was that? I forgot. So this thing is rotated, right? So we just kind of, so this is the initial, then we slide it up, and then sliding it up. So pz, we already found that. Px, that's what we need, and then r is just a hypothetical value. So we know that r, wait, hold on, this is harder than I thought. Yeah, how do we figure it out? So r should be somewhat proportional to z, pz, right? I want to go back to c4d. Maybe I can get some clues from here. Okay, I'm going to turn the shift to 0. You can see that looks absolutely horrible. Let's go with 10 subdivisions. I just want to see like the simple version of this, right? So I want to slide it this way. But you can see that when you slide it, it's like the size of this inner circle changes. And that's what makes this really confusing and hard. So say we shift this, so just kind of shift it. Gotta find the angle of this. But we already know the angle is, it's just, the angle is just this, which is the total angle divided by the subdivision, which is the theta. So how can we get this? Oh my god, it's really hard. So to find the theta, you already know theta is there, and then Oh my god. Uh, hmm. TZ squared. So this is the input. So this input. Let's just simplify things for. So this is input value right here. Input. This is also input, by the way. This theta, we know that. So that's also an input. Cosine and then R. Oh, okay. How does this work? How does this work? So maybe all we need is like a ratio of px into r. Does that make sense? Px and r, sorry. Because r, maybe r is the in. What if r is the input? Yeah. Does it make sense if r is the input? Probably not. Yeah. Yeah. There's no way we can do that. Okay. Oh man. Like I literally I thought of something. I totally forgot. Like I thought of like if I wait, sorry. If I do like a line and then like another line on top. This there's like a degree here, right? So if I just do this is an imaginary line, this is the theta. It's the same, right? And then I slide this. Hold on, I'm gonna make this a bit clearer. Uh yeah. Hmm. Alright, hold on. I gotta think about this really deeply. Hold on. Please oh, hmm. Oh, there's one viewer. Hello. Okay. Shift, right? We shift this. Let's make this a nicer angle. 180 is good. Shift radius. This radius isn't really radius, by the way. It's like some weird maths I have to come up with. Just divided by pi if we want. Okay. Okay. I think we're getting somewhere here. The shift value. Okay. Shift value. So we want to make sure that this angle, so let's say we're an 80, it's 18 degrees. So we want to make sure that this angle, oh shit, this angle is 180 minus 18, I think. I don't think that makes sense. Wait. Or maybe half of that. We get like a protractor. I think I do have. So I'll just measure my screen real quick. I think I lost my character. But yeah, that makes sense though. Okay, so we wanna drag. We wanna drag this until this becomes that, and that. The size of this, the bounding box. So before it was shifted here. This is just a cosine thing, right? Is there like a doodle thing? Oh, doodle, okay. Doodle paint. Oh, that's interesting. I didn't know 740 had that. I thought only Blender had that. Anyway, if we just try to like pull this, oh, that's weird. And make a line like this. This is just the length times cosine alpha. Oh, wait, hold on. It's just the length. Wait. The length times cosine alpha. Okay, it's kind of glitchy. Why is it so glitchy? I can't draw properly here, dude. Cos. Okay, you know what? Let's just use freaking. Let's just use a sketch with 0 stroke smoothing. I don't know if this is any better, but let's just give it a try. Hey, yes, this is better. Anyway, let's just make a quick thing here like that. So this length, yeah, it's also glitchy. I don't know what's happening here. Anyway, so this, the length of this direction, which is x. So length x, yeah, times the base cosine. Soka to adjacent opposite. Yeah, cosine theta. Okay, now what? And then we want to push it until this angle right here. Wait, let me zoom in a bit. Oh shit, fuck. Until this angle right here. I'll just make a tangent line right here. Make a quick triangle like that. And we want to make this angle. Should be half of it, right? Or I don't really know. Okay, let's shift this until there. Should be half of it, right? I don't know, man. Let's make this 18. So we get a better perspective of what's going on. Okay. So now it's 10 degrees. So this should be about 5 degrees. Let's just confirm that with a cube. And this is really stupid. I really have no other way of trying this. Okay, and then make it 5 degrees. Yes, nice. All right, so this has to be half of theta. So this right here is theta over 2. Okay, so maybe we're going somewhere right here. Or not, but it's fine. So what we're basically doing is, so we have this, and we have this. This is Lx, and this is Lx times cosine theta. We want to turn this into, turn this into this, and a bit of this. Like that. We want to make this imaginary triangle. We're going to make this theta over 2. This is Lx, and this is Lx cosine theta. So how do we do that, and how do we make sure that it's actually what's happening? But the thing about this sliding thing, right? This px offset is like an absolute thing, while this cosine is relative. Like it's a multiplication thing, but the px is, yeah, okay. Yeah, this is starting to get even more confusing. I wish I had more monitors, but this is, yeah, this is fine. I wish I had more monitors so I can like open up a lot of stuff. But yeah. Water break. Uh, LX. Man, how are we gonna do this? Is this even possible? Uh, I don't think this shift is really like a good thing. Like there has to be a formula to do this thing instead of like just freaking, doing it manually and stuff. There should be something. There should be something, right? 258. So that's like the length of this, and then everything. So you can see that the middle here is an exact straight line. Maybe not, maybe a little bit. It's because of the weights are different. Okay. So I think that could be a clue. Like this part right here. I think. But again, the radius is also unknown. And we don't know what this R value is exactly. Or do we? Wait, what if we use like a pi thing? Wait, so we have to know the length of this right here, right? Which we do, but we also have to get it from R, which is stupid. But maybe we don't have to. Maybe the px here. Yeah, but we still don't know the R. The R value. Can we use like a divide by pi thing? Honestly, I don't think so. All right, before we go any further, let's actually like make some definitions here. Pz is an input, px and r. R is still unknown, but we know that theta is just sigma angle per extrusion steps. So let's make that. So theta here is angle, right? So angle over subdivisions. So these are the values that we know. So angle and radius is what we don't know. Radius goes into either pz or r. Pz r shift is what we don't know. Oh my gosh. If this doesn't work, then I'll just end the stream because like what's the point? What's even the point? Uh, okay. I'm thinking. This right here is theta over 2. Okay, maybe that's something. No, that's 990 minus theta over 2. Could be a clue. I don't know. So theta, if theta is 45, I'm sorry, if theta is 90 degrees right here, it goes like this, which is accurate. Yep. But this R, this mysterious R, still, like, where does it come from? How can we derive it? I'm still thinking. No thoughts are going on in my head. Ideal situation, please. Yeah, that's what happens. That's over to great. Still don't get how I can get that. The shift value. This mysterious little bastard. Maybe we can like plot some graphs and see what happens. Maybe. But this is a 3 graph. So like maybe like in certain angles or in radius or in subdivisions, then there should be a formula for this shift. Should there? Yeah, there should be a general formula for this shift. Same thing with this angle. It's so unpredictable. Shit. Okay. Angle, radius, and subdivision. Angle, radius, and subdivision. Well, we don't really need. So radius here is just, what is radius? Radius is just this divided by subdivision going to pz. So we can just ignore the subdivision because it's just So angle and radius something something, and we'll produce some shift, the correct shift value. Maybe we can graph that and calculate what we need. But I think that whole thing is literally just this. But yeah, we get the px, which is the shift. But we have pz and r, which is two things. And there's the theta. Theta is just the angle, right? So pz and r should be somewhat correlated. But I don't know how to derive it from there. You know, we could actually try just plotting this thing. Start with like some angle, then we define some radius, some subdivision. I'm gonna say some subdivision, and define shift. Enable grid. I'm gonna move this cube to be more adjacent to this grid. All right. Okay, now I think we can just, you know, play around with it. So we're messing with radius here, radius and shift. I think radius and shift is like if we half this, so for example, we just half it. We also need to half this. Like that should be the exact formula. Wait, that does not work. Okay, let's double it instead. So if we say to double this, why is it so big? Anyway, so let's say we double this, right? And then we also double this. I think it should be the same. Yep. Okay. That's another clue. Radius and shift is kind of one in a certain angle. So now we have angle, subdivision, and either radius or shift. So yeah, the three. Yeah, now yeah, it makes sense now. Okay. Okay, yeah, it does make sense now. So we have some stuff. Yeah, one. So angle, radius, and shift is one. I'm gonna change this bit. So I'll put the radius down here. Angle, subdivision, radius, shift. Subdivision does change. Yep. And angle should change it because it is kind of ridiculous. But there has to be, yeah, there has to be something, right? There has to be something controlling all this, but I don't know what it is. I mean, honestly, this like by itself right now, it's not bad. Like it's still a good, you know, still a useful tool. But I just want to make it really perfect because you know I don't have time to like shift stuff, especially if you're like already working on a tight deadline and stuff. You don't have time to shift stuff. You just want to do it automatically, right? Okay, so somehow I'm able to get this. So the radius here, and so the radius here doesn't mess up. It goes along with the shift. I don't know how. Because if I do it from here, just the radius is something else. Oh, because the shift multiplies. Yeah, the thing I was talking about, right? But also, I forgot why, but I had some trigonometric functions here. I divided the angle by the subdivision, trigonometry, multiply. So I think that was just some like bullshit equations that I just came up out of nowhere. Yeah, I'm not supposed to use those. So what do I use? How do I do this? What if someone already made like a paper on this and I just missed out on it? But this is a really weird one. Geometry is hard. Oh my god. Okay. Anyway, so this good version, I'll just keep it, and this is where I'll work the better version. Okay. So far, we're going nowhere. Oh. L. Okay, so we can, by the way, we can substitute px for another thing using cosine rule from a and this and this. Shall we try that? I'll move this here. And yeah, I should make like some thing. Okay, we can substitute px for whatever that is. Yeah, let's do it. So pz squared plus px. But it already has a square, so the square will cancel out. So the x is pz squared plus this entire thing squared. Oh wait, no, that thing squared. Will we just end up with a value of like pz? I hope not. Wait, hold on. I'm thinking. So pz squared, right? And then another one of this, 2r squared minus 2r squared cos sinus theta minus. Oh, it gets more complicated. Oh shit. Wait, hold on. Bathroom break. Okay, I'm back. Okay. So yeah, let's do the substitution thing again. But this one kind of sucks, so I'm gonna erase this. Let's erase this first. Okay. So pz squared, px substitute for something else. So let's simplify this like just one letter. So z squared plus px squared square root oh wait, this word is clear. Okay, yeah. So we need z squared plus, yeah, I'm just gonna simplify it to a squared plus first. A squared. Wait, what? Hold on. I'm really confused. Minus 2za and then a cosine of theta over 2 equals a squared, which is, yeah, those things. Wait, let's confirm this. So it's supposed to be a square, but okay, so it's square minus a. So this is a, the square root one. This is a squared is just that without the square root. And then okay, so from this we can get r. Yeah, we can get r. Wait, can we? Yeah, we can get r because pz is known and theta is known, and px is derived from all this stuff. Yeah, let's start completing the equation, I guess. So z squared plus, oh wait, I can just do 2z squared. So 2z squared plus a squared is 2r squared minus 2r squared cosinus of theta. And then all this is minus 2z a is that, so square root of 2r squared minus 2r squared cosine theta. All this equals 2r squared minus 2r squared cosine theta. Okay, so far we have this, which is really bad. I mean, how do we even get a value from this? I think we're just going nowhere. Okay, first of all, this entire thing just cancels out. That's a bad sign, because stuff would probably get canceled out a lot. Okay, 2z squared, so 2z squared equals 2z square root of whatever, 2r squared minus 2r squared cosine theta, multiply. And then this is a z, so we can that, and we're left with 1z. So the final thing is this. So z equals a? That doesn't make sense. Z equals a. Wait, what? Wait, hold on. No. No. There's no way. But why is that? Wait, hold on. I think I got something wrong here. Oh, it's over it too. Holy shit. Wait, hold on. Okay. 2z a and the cosine. I forgot to include the cosine. Oh wait, oh shit. Okay, shit. Okay, go back. Go back. Right about here. So okay, 2z squared plus 2, it's just r squared to r minus blah 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 minus 2z a is that, and then multiply by another cosine theta over 2. Okay, that I missed that one. Yeah, I'm sorry. That's why it got really weird. So I'll just delete all this and continue drawing. I'll just make a limit, right? So 2 squared, and then another cosine theta over 2 equals, well, it's pretty much the same thing as the one I deleted. So yeah, 2 squared cosine, and actually I don't really have to break this down because they're just gonna get canceled out anyway. This and this. Okay, so this is what we got. 2z squared equals, minus goes there, yep, that's correct, 2z times cosine theta over 2 square root of 2r squared minus 2r squared cosine theta. Okay, now we do the same thing again, so now we only have a z, 1z, So that's the entire thing. So z pz equals cosine theta over 2 square root of 2r squared minus 2r squared cosine theta. There it is. Okay, so okay, now what? Like we got that. So now what? I guess I don't know. So we don't have to use px. I mean, like we have to use px later, but like px is easy. Just gotta do that. But now we have simplified it, so we don't have to include any other, constant. So now we only have pz, r, and theta. And z, as you remember, z is input, so z is known. Theta is also known. So, oh yeah, this is known. So we can totally find this r value here. But the problem is, I think now I have to inverse the entire thing. Oh wait, not really, because I can just input the r. Yeah, I should just input the r and just use the z for everything. Yeah. Okay, let's do something else. So z, I'm gonna simplify it. So cosine theta over 2. What's like the rule for dividing cosine? So there should be something, right? But I forgot. Okay. So this is a 2r squared of 1 minus cosine 0. And 1 minus cosine 0 shouldn't be able to be turned into anything, as far as I know. Wait. Right? Oh man, I don't know. Okay. I think it can be turned into something like a sine. Oh yeah, no. Yeah, oh wait, no, or like a cosine thing. Hopefully not. Anyway. Shit. So r squared, so the r goes out. So we can go z equals r times cosine theta over 2 of square root of, so r squared goes out, 2 is still there, so 2 minus 2 cosine theta. There it is. Oh my god. Okay, honestly I want to try graphing these and see if it actually makes sense at all. Let's go to, so let's assume that z is known. So z is the one known, right? R, I don't know if this will work, honestly. Let's assume that one of the values are known. So what are we picking here? So we need to find the r. So let's say r is the one known. R and the angle is the one known. So let's make r the x and theta as the y. First, I'm gonna make this degrees. Let's make the z something like 1 first. And then, so we go z equals, so I think it's better if the cosine is an x. So let's go y first. Y cosine x over 2. Oh, it's not appearing anything? Nothing's appearing? Huh, that's weird. But it doesn't show any errors or anything, so I'm assuming it's fine. And then a square root of 2 minus 2 cosine x. And nothing is really appearing right now. Oh! Okay, so for some reason this constant doesn't really work. If I just plug in 1, wow, okay, something's happening. So y is hold on. Y, what is Y? Y is the R, so that's actually, so this is the radius. The x-axis is the angle, theta. So as theta decreases, radius increases. Does that make sense? Theta increases, radius increases. Honestly, I don't know. I assume it's right. Whoa. Wait, there's something more here. That is 180. Okay, so it's doing something. I don't know what it is, but anyway. Wow. Well, it works. It totally works now. I think I just gotta plug this into whatever. But we still need to figure out the px. So px is just z plus that. So, okay, let's make... Okay, so once we know this, we can finally know the px, right? So let's make a new section, like somewhere in here. Px. Yeah, px should be good. All right, let's copy it first right here. So, hold on. So we need the px. So px is, what is px? It's just the square root of all that shit. A lot of shit. Square root of z squared plus 2r squared minus 2r squared cosine theta minus 2z, all that, is 2z square root of 2r squared minus 2r squared cosine theta. And after that, another cosine of theta over 2. Okay, just plug that and everything. Okay, so this is the value of px. It is a lot. Can we substitute anything? So z is this. Yeah, no, yeah, this is the fixed value pretty much. All right. I think that's good. I'm gonna name this okay. Go. Okay. Nice. Well, now we just gotta plug this into the espresso, but I'm scared that it actually won't work at all. So I don't know what to do. Okay, you know what? I'm gonna take a little break for now because I'm kind of tired. So see you in a bit.